introduce our article. Principles of construction of an adaptive multi-level system of monitoring and diagnostic of complex technical objects. The thesis is devoid of issues of development and research as the basis of a model for building an adaptive system of multi-level monitoring and diagnostic of complex technical objects. The purpose of the thesis is to study the organization, architecture, principle of construction work models, technical and economics requisition to ensure quality monitoring through the parameters of complex technical object in the real time, to select a model of the research object. To achieve the goal, the following scientific tasks are solved. Analyze the subject area and determine the main characteristics of the adaptive system of multi-level monitoring and diagnostic of complex technical objects. Conduct a scientific problem statement determining the requirements for adaptive system, taking into account the principles of maximum use of the system resource. Apply the method of two-stage modeling of the CTO automatic and simulation models of the object. Fig 1 defines and presents a generalization structure and function scheme of the SMMD CIO. The monitoring subsystem contains block to perform the following function: control of the state of the technical system, forecasting the state of the technical system, adaptation of the models of operation of function blocks of the diagnostic system to change in the characteristic of CTO, select of a goal strategy and elimination of consequence from unregulated conditions of object at the level of the technical system. The diagnostic subsystem contains block to perform the following function: control of a state of the industrial object, multi-level monitoring and diagnostic, forecasting the residual resource of the object, selection of the local strategy of liquidation of a special identified irregular state. All results are sent of the automatic control system of the technological process. As a result of studies of model approach to the construction of models of complex objects, a two-stage method of construction of CTO models was determined, according to which at the first stage a conceptual model of the object consisting of the two subsystems is developed: automatic and imitation. The automatic one determines the algorithm of transition of object states and simulate one reproduction signals from the object corresponding to the transition states. The model of each nest automaton is described by the following expression 1. The transition function S from T and Y from T of the NA output in the automatic time T mode are determined as follows. Equation 2. According to the value of the vector Y of each nest automatic in the simulation subsystem, the appropriated models of the time series PIT of the CTO parameters is selected and adjusted in the form of the following polyharmonic polynomial is equation 3. All coefficients of the models are determined using the method of the least squares. This the output signals of the model corresponding to the generalization parameter P for the moments T is determined as a superposition of the simulated signals. Equation 4. The development models has a wide range of function capabilities. In comparison with no analogies, has flexi setting, can adapt to change in the structure of the CTO and can be implemented with available hardware. The main features of the present methodological basis include the following characteristics. The present methods and tools can be used at the stage of decision, the SMMD, starting with the project study of the system, ending with their implementation in production and recommendation for maintenance. The main concept of methodological development is the synthesis of project solution based on the adaptive work models and subsystem self-organization. With the use of formalized approach of automat theory is a function logical models of CTO is built and described, which allows to determine approach for creating simulation models of CTO and methods of their control.